Today we are discussing about a very important section in optics. You know what is optics? It is a branch of physics which deals with the study of light rays. So very important phenomenon in that optics is called a total internal reflection. There are so many practical applications in that total internal reflection. So we can study what about total internal reflection. So we can consider two media as denser medium and rarer medium. You know what is denser medium and rarer medium? The medium which has got density is high is called a denser medium and low density is called a rarer medium. So when a ray plate passes from a denser medium to a rarer medium, the refracted ray bend away from the normal. So here is the angle of incidence. It is the angle between the incident ray and normal. If the angle of incidence increases, the angle of refraction also increases. Like this, for a particular angle of incidence, the refracted ray just grazes the surface of separation of the two media. So that particular angle of incidence is called a critical angle. But when the angle of incidence is greater than the critical angle, there will be no refraction takes place, but the light ray gets reflected back to the same medium. This particular phenomenon is called a total internal reflection. So in the case of this total internal reflection, the ray plate must pass from a denser medium to a rarer medium. When this angle of incidence increases, the angle of refraction also increases. And for a particular angle of incidence, the refracted ray just grazes the surface of separation of the two media. That particular angle of incidence is called a critical angle. But when the angle of incidence is greater than the critical angle, there will be no refraction takes place, but the light ray gets reflected back to the same medium. So that particular phenomenon is called a total internal reflection. So what are the conditions for the total internal reflection? The ray plate must pass from a denser medium to a rarer medium, but the angle of incidence must be greater than the critical angle. So there is a relation between this refractive index and the critical angle, which is given by n equal to 1 by sin c, where n is the refractive index and c is the critical angle. So there are so many practical applications for this total internal reflection. The first one is that for bicycle reflector. In the case of bicycle reflector, there are so many right-angled isosceles glass prism whose critical angle is less than 45 degree. And in front of it, there is a red glass plate is there. So when the light rays are incident on this total reflecting prisms, it will be deviated through 180 degree and will be comes back. So if the light rays are coming back through the red glass plate, that appear as red in color. That's a very important application for the total internal reflection. And also we are used in periscope, in submarines or sonars, like that in optical fibers. In medical science, optical pipe works on the basic principle of the optical fibers. That optical fibers works on the principle of total internal reflection. There are so many applications and very important in the case of this optics.